Euclid Book 5, definition number 5. And for those of you who have this available to you, that's fine. If you don't, I'm going to go ahead and read this to you. You have no idea how big of a definition this actually is. It says magnitudes. Of course, we now know, as we have been working with this, line AB is a magnitude, so is line EF. Okay, and we're also going to be talking about line AC here and line EG. They are both magnitudes. Now, I know that magnitudes can be other things, but in this case, we're going to strictly talk about lines. Later on in another lesson, we're going to talk about something else. Magnitudes are said to be in the same ratio. That's right, we're going to be talking about ratios today. The first to the second and the third to the fourth. The first to the second, the third to the fourth. Okay? When, if any equal multiples, whatever, are taken of the first and the third, okay? Here's the first, and here's the third, okay? And any equal multiples, whatever, of the second and the fourth, second, fourth, okay? The former equal multiples exceed, okay, are alike equal to or fall short of the latter equal multiples respectively taken in corresponding order. Now, if you read that, you have no clue as to what these people are talking about. So let's begin. Alright, now I know this is not an exactly perfect drawing here. It was the only way I could draw this so to get all on one page. What I want you to do is I want you to draw on one piece of paper a 2-inch square. Okay, so this is going to be 2 inches, 2 inches, 2 inches, 2 inches. And then on another piece of paper I want you to draw a 4-inch square. Okay, here's 4 inch, 4 inch, 4 inch, and 4 inch. Okay. Now, I don't know if you've ever been taught about ratios or not. We're going to teach them here. Okay? Now, normally in elementary school, when they propose ratios to you, they will give it in a fractional format. Now, in this illustration, you're going to see why it is such a problem when you go into advanced mathematics to have a fractional format. Okay. AB is to EF as AC is to EG. Okay? AB is to EF as AC is to EG. Now, can you see the problem here? Well, I can see it right off the bat. We have to draw a line above these letters to indicate that this is a finite line. And we have to do this for all 4 of these. But then we have to draw these fractional lines as well. Well, you're going to get that confused with the marking of this. So we don't want to do that. Therefore, they invented a different type of way to express ratios. And they use the colon to do it. So this down here is the same as this up here. So we have line AB, and I know I should have put a marking over here, the EF. So line AB, colon, EF, double colon, which indicates that this is one ratio, and this is the other one, AC, colon, EG. Now, what we're going to say, okay, is if you take 2 of these, you'll get 1 of these. And if you take 2 of these, you'll get 1 of these. So if you increase this by the number of 2, you'll get this. If you increase this by the number of 2, you'll get this. Right here. 2AB, colon, EF, double colon, 2AC, colon, EG. That's right. Now, you say, well, how can we do this? All right. Let's say, like I was telling you a minute ago, that AB is 2 inches long and EF is 4 inches long. Okay? And then you go and measure the diagonal here. You find out that the diagonal here is 2 3/4. Well, if this is 2 3/4, you double the size of that, and you're going to get 5 1/2. Okay? So, 2.75 over 5.5. And I'm going to show this right here. Alright. AB is 2 inches long. EF is 4 inches long. Okay? AC is 2.75 inches long. And EG is 5.5 inches long. Alright. Now, if you take both of these fractions times 2 over 1, okay, you're going to multiply fractions here. You're going to have a fraction of 2 over 1 here and 2 over 1 here. When you reduce both of these fractions down, they're going to be the same. You say, wait a minute. Are you kidding me? No. Because right now, 2 over 4 is 1/2. And if you were to divide 2.75 by 5.5, you get 1/2. And if you take 1/2 times 2, you're going to get 2 1/2, 2 1/2. Doesn't change. They're both equal. Now, if you increase this top side by 3, let's say we multiplied 3 over 1 and 3 over 1 over here, you increase this by multiplying it by 3, you increase this by multiplying it by 3, well, nothing changes. Okay? They're still going to be equal. Okay? And I could go on and on and on and on. Alright. So that's what he means by what he was talking about. Alright. I will tell you more in the next video, so stay tuned.